sign is replaced by an inequality sign. Okay, the inequality sign can be a greater than sign, or it can be a less than sign. Sometimes you can have less than or equal to, or greater than or equal to. All right. So you also need to know that in grade 11, the general equation of a quadratic function changes as compared to in grade 10, right? I don't want to seem like I'm teaching functions here. In grade 10, your general function was y equals ax squared plus q. In grade 11, because of horizontal shift, okay, the equation will become y equals ax squared plus bx plus c. It becomes slightly more complex. Now, we can incorporate the quadratic function in grade 11 and quadratic equations together with the inequalities, okay? Whereby this y here, we can replace it, okay, by a specific number. Also, we replace that equal sign by an inequality sign, okay? I hope that you still remember from last year that if this A here is positive, the graph, okay, if it's positive, the graph of the function will have a smiley face. When it's negative, the graph will have a sad face. Okay? So some of those concepts you can also incorporate them on solving quadratic inequalities. But at this stage, we haven't done the quadratic function. So I'll concentrate my teaching of solving quadratic inequalities using the number line method. Okay? All right. Also, I just need to remind you that last year you were told that if you divide on both sides of an inequality by a negative coefficient, the inequality sign changes. Okay, you still need to know that as well. All right? So those who are confused people here. Okay, before I move on to an example. Huh? If you want to copy this down, I'm giving you an opportunity to copy that. Hmm? Okay, give me a second. All right. Okay. Whilst you're copying, right? Whilst you're copying this, I just need to explain what's happening with regard to this graph here. All right. Do you agree with me that if you are given this equation, y equals ax squared plus bx plus c, okay? I hope you are aware that if we put 0 here, where there is y, it means y is 0, right? What that means is, because y is equal to ax squared plus bx plus c, if we substitute the y by 0, it means the y itself is equal to 0. Therefore, the trinomial will also be equal to what? To 0. Then, if, okay, on the Cartesian plane, okay, the sad part is that this part I'm end up talking about functions that you have not done in space. I hope you agree with me that in the first quadrant and the second, y is what? Positive. Okay? Then in the third quadrant, y is what? Negative. In the fourth quadrant, y is negative. So if I write in inequality like this, ax squared plus bx plus c is less than 0, what that means is we are saying the y values are what? Negative. That's what it means. Okay? If I put ax squared plus bx plus c is greater than 0, it means the y values are positive. Therefore, if I draw my Cartesian plane, right, for the case where ax squared plus bx plus c is greater than 0, right, generally, that function will have two x-intercepts, okay? So what that means is if I draw my Cartesian plane, so let me just put the Cartesian plane. So let's say this is my y-axis, this is my x-axis. What it means is if y is positive, it means we are talking about values of x going to the what? To the left, okay? And also values of y of x going to the right. Those x values will make y a positive, okay? But then between this x-intercept and that x-intercept, y is negative. So for this one here, okay, for that one there, we'll be talking about this region here. Okay? Then, for the case when the trinomial is positive, we'll be talking about from here going all the way up to positive infinity. And also all the way, when I say up to positive infinity, I'm referring to the x values. Okay? Here we'll be moving from a very high value of x, which is negative, towards a negative infinity. So y will be positive. That is from minus infinity up to the x value here, which is an x-intercept. And then y will also be positive from the second x-intercept all the way up to positive infinity. The space between the two x-intercepts, that's when the inequality will be negative. All right? So, I don't want to go into the details there because of the fact that it will seem like I'm teaching functions when we're actually doing quadratic inequality. Okay, but this is the basic idea. Is it making sense? Right? Okay, so can I do an example? Right. Okay, so let me move on to an example. Okay, let's start with the first one, A1. Right, so if you are given x squared minus 4x plus 3 is less than 0, I'm going to teach you the number line method first. Then maybe I can also use the graphing method as well. Right, so here, this is an inequality. To solve it, okay, it's not as straightforward as a quadratic equation. Okay, so what you do in your head, you treat it as a quadratic equation, but it's not a quadratic equation, it's a quadratic inequality. So the trinomial on the left-hand side can be factorized. So you get x minus 3 times x minus 1. Okay? So we are factorizing the what? The inequality, the trinomial on the left. Now, if you, okay, I think let's start with the number line method, then I'll come to the graphing method. Then, from here now, you need to determine what are called critical values. Okay? Critical values are actually the solutions or the roots of a quadratic equation. That is, if you treat this quadratic inequality as a quadratic equation in quotes. So, for a while, you treat it as a quadratic equation by replacing the inequality sign by an equal sign. So you need to determine what are called critical values. So those critical values are actually the x values if the inequality was a quadratic equation. We have solved quadratic equations. So for a while, we will treat it as a quadratic equation. But it's not a quadratic equation, it's a quadratic inequality. So you need to determine the critical values. Okay? Now, your critical values you just equate these binomial factors to 0, as if you are solving a what? A quadratic equation. So your critical values will be x minus 3 is equal to 0, or x minus 1 is equal to 0. Therefore, your critical values will be x equal to 3 or x equal to 1. Now, these critical values, if you were to consider this as a function, that is the quadratic inequality as a function, there will be your x-intercept. I hope that you remember from last year that when you had an equation like this, y equal to, okay, let's make it 2x squared minus 8, like that, right? We could solve we could simplify the right-hand side by factorizing it. Okay, you get a difference of 2 squares. Then you can simplify this further and write it as 2 times x minus 2 times x plus 2. Right? Then to find the x-intercept, you equated y to what? To 0. Then you solve. Okay? The same concept now applies here. Okay? But you have to connect your knowledge of the quadratic function and quadratic equations into the quadratic inequality. Okay? So we have got our critical values. Please take note, the critical values are actually the x-intercepts if you treat the quadratic inequality as a function. Okay? So, we go on the number line. Okay, we draw a number line. Now, when you draw a number line, you need to know that a quadratic inequality has a range of solutions. Okay? It has got a range of solutions. Therefore, we can draw a number line. In this case, my minimum value is the 1. I'm on the number line here, along the x-axis. My maximum is 3. Please take note, I'm on the x-axis. I got my 2 critical values, which are also the x-intercept. Okay? So, with the number line method, you just draw a vertical line there using dashes. Okay, like that. Okay, we are on the x-axis. Then, you use a trial and error method to determine the solution. You use a trial and error method. So the trial and error method works this way. Since I have got my critical values as x equal to 3 and x equal to 1, I'm sure you can agree with me that to the right of 3, the x values are greater than 3. Okay? I hope you can agree with me on that. Right? Then, between 1 and 3, we are going to have an inequality to be 1 is less than x, and x is less than 3. That is between 1 and 3. That interval, it has got many x values. It is 1. So we say the x value is between 1 and 3. Then to the left of 1, it will be x is less than 1. Okay? Now, I'm sure you can agree with me that all the values to the left of 1, they are less than 1. Okay? We are on the x-axis. Okay? Then, you use a trial and error method whereby you choose a value for each of these 3 intervals. You choose a value that you can substitute into the original inequality. Okay? That value, if it makes the inequality valid, it means that specific interval will be true. Okay? So, let's start with, okay, generally I prefer to start with this one. So, can someone choose a value which is greater than any value? Okay, she started with 5. Okay? The good thing is that 7 is more than 5. So if 5 is valid, then 7 is also what? Valid as well. So you go to the original inequality. Please take note, you can substitute the original one or into the one that is factorized. Let's say I substitute the one that is factorized. It's much better for me. If I put 5 here, 5 minus 3 gives me what? A 2. Right? Please, you need to concentrate here. If I put 5 here, you get a what? A 4. 2 times 4 is equal to what? 8. Is 8 less than 0? Is 8 less than 0? No. No. So what that means is all the values that are greater than 3, they will make the inequality valid. So x is greater than 3 is not a solution. You can test any other value that's greater than 3. Okay? Any value you want. Right? Then let's move on to the second interval. Remember, I'm starting from the far right, going to the left. Now, can you choose any value between 1 and 3? It's always better to choose an integer. Okay? Any value between 1 and 3? 2. Okay? So let's say you let's put 2 there. So if we put 2 where there is x, 2 minus 3 gives us minus 1. Right? Then 2 minus 1 gives us 1. Please take note, this is a number line method which involves some trial and error. Minus 1 times 1 gives us a what? A negative 1. Is negative 1 less than 0? Yes. What this means is this interval here is going to be a solution for that quadratic inequality. Then the last interval, okay, we also choose a value which is less than 1. Can you choose any value? Negative 3. Okay, so we're going to substitute negative 3 where there is x here. So minus 3 will give us minus 6. Minus 3 minus 1 will give us minus 4. Minus 6 times minus 4 gives us a positive 24. Now, is positive 24 less than 0? No. So this interval here is going to be invalid. Okay, this interval here is going to be invalid. So therefore, our solution to that inequality is going to be x lies between 1 and 3. Okay, so this will be the answer. Please be aware that these are quadratic inequalities. Therefore, you have a range of solutions. You won't have one solution to that specific quadratic inequality, but it will be a range of solutions. Okay? So I've used the trial and error method with the number line. Okay? Which is a method which I think is a little bit easier at this stage when you haven't done a quadratic function in grade level. Right? Now the same question, we can do it using the graphing method. Now with the graphing method, you need to be aware that, okay, it's a little bit easier as well, but only if you understand what it's all about. So I'm just going to talk about method 2, the same question. Okay, method 2. So you can consider this as method 1. If you like this method, then fine. Okay, method 2. Okay, method 2. So with method 2, it's more like it's a graphing method. You have to know your quadratic function. Unfortunately, you are in grade level term 1. So the original function is x squared minus 4x plus 3, right, is less than 0. Okay? So again here, we factorize, obviously. Okay? So we factorize. Then we determine the critical values. The critical values are actually the x-intercept. Okay? Determine the critical values. Obviously, I'm not going to rewrite it. It's x equal to 3 or x equal to 1. Right? Then you go to your number line. Okay? Both methods, they actually involve the number line. Now, I'm sure you can agree with me that since the coefficient of x squared is positive, if I were to draw the graph, okay, it will look like this. In this case, it will look like that. That will be the quadratic function. And obviously, we have an x-intercept here, another x-intercept here. We are connecting our knowledge of quadratic equations, quadratic inequalities, quadratic function. Okay? Now, I'm sure you can agree with me that this quadratic polynomial, it is less than 0, which means y is less than what? 0. And y can only be less than 0 between this point all the way up to that point. Are you following that? Y can only be 0. Remember, the trinomial is equivalent to y. Okay? Remember what I said earlier. The trinomial is also y. Therefore, where is y negative? Remember, this is the x-axis. We are on the what? On the x-axis. Please take note of that. We are on the x-axis. So, if this is the x-axis, it means that y is positive above the x-axis and y is negative below the what? X-axis. Our quadratic inequality is negative. Therefore, the solution will be x lies between 1 and 3. So we can just write the answer. X lies between 1 and 3. Okay, this is an easier method if you understand the relationship between the quadratic function, quadratic inequality, and the quadratic equation. Yes? No, you don't need to. Okay, remember, when we are solving quadratic inequalities or quadratic equations, we are solving for x. So we are not worried about the y value. Okay? That's why we only put the x-axis. Okay? Alright? Any question? Is it making sense? Right? Later, when you do the quadratic function, you probably get a better picture of it. But at the moment, we haven't done the quadratic function in grade level. Okay, now you can decide now whether you prefer method 1 or you prefer method 2. That will be your choice. Okay? Alright? Okay, let's do another example. Okay, let's do another example. Maybe the one with this one, yeah, maybe this one, that one. Right, so we have minus x squared plus 5x is less than or equal to 6. Okay, so we have minus x squared plus 5x is less than or equal to 6. Okay, so first thing, we need to make this inequality, okay, we need to write it as a trinomial. Okay, so we need to have a trinomial on the left first. So this would be x squared plus 5x minus 6 is less than or equal to 6. Then the next thing, it's always better to work with the quadratic inequality in such a way that the coefficient of the x squared term is a positive. So if I divide each term by minus 1, this sign will change. So you end up having x squared minus 5x plus 6 is greater than or equal to 6. Okay? Then we factorize this. Okay? If you can't factorize, you can use the quadratic formula, remember. Okay? To get your principal values. So this is going to become x minus 6 times x, actually x plus it's minus 3. Okay, it's minus 3 there. So x minus 3 times x minus 2 is greater than or equal to 6. So our critical values, well, from now on, I'll just write CV, okay, as an acronym for critical values. So CV stands for critical values. So the critical values will be x equal to 3 and x equal to 2. Okay? Now, let's use the number line method first. Let's do it for time. I don't have too much time though. Well, if I use the number line method, okay, I'm going to have my 2, my 3 there, and then my vertical line with dashes, okay? From here, this will be x is greater than or equal to 3, and then between those two, it will be 2 is less than or equal to x, x is less than or equal to 3. Then x is less than or equal to 2. Then we use trial and error. Okay, I'm going to do this quickly because of time now. Right? So let's choose the value. Let's start with 3 itself, the first interval to the far right. If I put 3 here, 3 minus 3 will give me 0. So I'll end up having 0 times 0, 0 times 1, okay, which will give me 0. But we have got the equal sign, which means when x is 3, that interval is correct. But we need to consider now values that are greater than 3. So if I look at x equal to say a 4, if I put a 4 here and a 4 there, I'll get a value which is greater than 0. Okay, which means this will be a solution. Do you see what I'm doing? Yeah, you choose any value of x that's greater than 3, you put it here, you put the same value there. Okay? So if I put 4, I'll get a positive 1. If I put 4, I'll get a positive 2. So that will be valid. Now, in most cases, as you practice, you are going to realize that if this interval is correct, the middle one will be incorrect. The one to the far left will be correct. If the middle one is correct, the other two will be incorrect. Okay? So let's test the middle one now. If I choose a value between those two now, unfortunately I don't get an integer now between 2 and 3, but I'll choose 2.5. If I put 2.5 here, I'll get negative a half. If I put 2.5 there, I'll get a half. So minus a half times a half gives me negative a quarter. Negative a quarter is less than 0, which means this interval here will be invalid. Okay? Then here, if I choose a value that's less than 2, like a 1, put 1 here, you get negative 2, put 1 there, you get negative 1, multiply the 2, you get a positive, so this is a solution. Therefore, our solution will be x is less than 2, or x is greater than or equal to 3. Okay, so you have 2 inequalities as the solution. Okay? If we use the graphing method, I'm sure you can see that our trinomial is positive. Since our trinomial is positive, we are talking about this side, I don't know what you can call them the horns if you want, right? Okay, you want to call them the horns. Okay, so it will be to the left of positive 2 and to the right of positive 3. All right?